Hello, Period 4 Algebra 1 Honors. We're going to go over our 9.3a samples where we're going to solve by graphing. We're going to use the zeros of the function and or the vertex to graph the solution. So here we go with sample 1. This one is going to have no solution. Here's how we know that. We're going to go ahead and try to factor the equation x squared minus 5x plus 7 equals 0. It does not factor. That doesn't mean that there isn't a solution. It just means that we can't use factoring as our method to find the zeros of the function in order to graph the equation. So instead we're going to use negative b over 2a to find the vertex. So plugging into negative b over 2a, we have negative 5 over 2 times 1, which simplifies to 5 halves, which is equal to 2.5. Building our table of values, then we're going to put 2.5 in the middle because that's our vertex. We'll pick convenient numbers above and below 2.5. I chose 2 and 3. We will plug those numbers into our x squared minus 5x plus 7, and here I am showing all of my work for working out when x is 2, 2.5, and 3, what are the corresponding y values. Once I've done that, I'm going to graph those points, and here I am graphing those points and finding out that parabola never touches the x-axis. Therefore, since there is no x-intercept, there is no solution to this particular equation. Sample 2 will show us an example of how a graph is going to tell us there is only one solution to the quadratic equation. So we are factoring x squared minus 10x plus 25 equals 0 successfully this time into x minus 5 times x minus 5 equals 0. Setting each of those factors equals to 0 will result in one value only that works, and that is x is 5. When we get only one value when we are factoring our equations, we get the same value twice, that means that value is the vertex of our parabola. So we're going to put that x-coordinate 5 in the center of our table of values, and we're going to pick a point smaller and larger than 5. In this case, x value of 4 and x value of 6 will help us find points on either side of the vertex. Again, here I am working out in the middle of my table of values how I get my y values. So when x is 4, y is 1. When x is 5, y is 0. I didn't have to work that out because I said when x minus 5 is equal to 0, x is 5. So that's already known information. That's why you see nothing in the middle of my table of values here to know that when x is 5, y is 0. When x is 6, y is 1. Here is these points plotted on my parabola, and that gives me the solution that x is equal to 5 because there is only one x-intercept, and that x-intercept is at 5, 0. I'm going to go ahead and fix that up here because it should read 5, 0 instead of 1, 0 there. All right, next step, sample 3. On sample 3, we have x squared minus 8x plus 15 equals 0. When we factor that, we factor it into x minus 3 times x minus 5 is equal to 0. Setting each factor equal to 0, we arrive at the values of x to be 3 or 5. And then we're going to use the zeros of that function to figure out in our table of values what values will help us graph this parabola, so 3 and 5 being the zeros of the function. Notice there's no work for me to put in the middle of my table of values there. I already know that when x is 3 and 5, y is 0. I found that out up here when I set x minus 3 and x minus 5 equal to 0 to find their values. I will have to work out my vertex y value, so when x is 4, here I am working out my corresponding y value, and I'm finding out that when x is 4, y is negative 1. Then I'm going to plot those 3 points, and here plotting those 3 points, I see a parabola opening upward. It intersects the x-axis at 2 places, and that's why we see those 2 values, x is 3 and 5, as solutions to this equation. Okay, that's it for our samples on this lesson. Now it's time for you to review this and make sure you're ready for today's quiz. See you next time.